Dear members of the audience, today I shall be discussing about investigations of an outbreak of food poisoning, which is very important aspect, both from your examination point of view as well as from your actual working as an Indian medical graduate. We have selected this topic for today's talk for two reasons. Firstly, its importance for examinations, and secondly, since the stepwise comprehensive coverage of the topic seems to be missing from most of the contemporary textbooks. So, coming to the investigations of an outbreak of food poisoning, it takes the same general approach as any other epidemic as has been outlined in chapter 20 of our book. However, there are certain differences in approach vis-a-vis the general steps for investigations of an epidemic. The most important starting point in a food poisoning epidemic is identification of the meal which most probably caused the episode of food poisoning. Any wrong judgment at this very first step will not only identify the wrong meal but will take the whole process of investigations into a wrong direction and negate the very objective of the investigation, which is to find out what went wrong from the public health point of view and what remedial measures are to be taken so that such episodes do not happen in the future. Identification of the correct meal may not be as simple a common sense conclusion as it seems. For instance, if 36 medical students eating in a common mess are admitted with common symptoms referable to the gastrointestinal tract between 9 a.m. and 3 p.m. today, that is 28th of August 2021, which meal should we investigate? Whether it should be the breakfast of 28th August, which was eaten between 7 and 7:45 a.m., or should it be the evening snacks of yesterday, that is 27th August, or dinner of 27th August, or lunch of 27th August? Secondly, the idea of investigation is not simply to incriminate a particular meal or a given foodstuff. The goal is to trace back the entire history of that food item to find out why contamination occurred so that the episode does not repeat. We shall deliberate on these steps to be undertaken for investigating an outbreak of food poisoning, illustrating it with a real life example in a problem solving manner. The location, timings, and general settings have been modified in the example for reasons of confidentiality. You can read the original published paper at the reference shown on the screen. We will keep on solving this example as a problem-based exercise and, in the process, keep identifying the various steps to be undertaken in an outbreak of food poisoning. So, we start with the example of a real life situation with the names, dates, and the locations changed to maintain confidentiality. Now, any investigation starts with a preliminary information. So, on 23rd of August 2021, the Dean of a medical college got the information that since today morning, from about 8 a.m., cases with symptoms referable to the GIT have been coming from the first year boys hostel. Out of the 100 male students of MBBS first year staying in that hostel, 13 were on leave. So, out of the 87 boys, 36 developed symptoms and were admitted to the isolation wards of the medical college. Since the incident was concerning, the dean directed the casualty medical officer to investigate the episode under the overall guidance of the head of department of community medicine. Preliminary investigations revealed that the first three cases had onset at 8 a.m. Two cases had onset of symptoms between 8 a.m. and 9 a.m. Thus, total of 5 cases occurred between 8 and 9 a.m., starting from the first case at 8 a.m. and remaining 31 cases had onset between 9 a.m. to 4 p.m. as per the hourly periods. The distribution of the occurrence of cases as per the hourly time period is shown in the table being projected. It is seen that between 8 to 9 a.m. there were 5 cases, which rose to 7 in the hourly period 9 to 10. The maximum number of cases, that is 11, happened between 10 to 11 a.m. Then there was sustained decline, and by the time it was 3 p.m., only one case happened. Now, with this information, we developed the epidemic curve and which is being shown on the screen here, and it is seen that the time period has been plotted along the horizontal axis, that is the x-axis, and the number of cases as per the time period have been plotted along the vertical axis or the y-axis. It is seen that in this epidemic curve, there is very quick and sharp rise, a very sharply defined peak, and a quick fall, though it is less quick as compared to the uprise wave. The peak occurred at around 10 between 10 and 11, that is around 10:30 a.m., and a total of 11 cases occurred at the peak. And by the time the peak was reached, a total of 19 cases had occurred. Now, this characteristics is a very typical characteristic, and this is known as a point source common vehicle epidemic. And such type of epidemic curves are classically seen in outbreaks of food poisoning. In such an epidemic curve, the peak of the epidemic, that is here, this will correspond with the median incubation period of the disease, and the range, that is the duration between the first case and the last case, which in this case is between 8 a.m. to 3 p.m., that is 7 hours, that corresponds with the range of incubation period of the epidemic. Now, out of the 36 patients, 30 were admitted to the isolation ward, and while another 6 were detained for treatment at the casualty ward. All the 36 cases, that is 100% of them, had 6 to 8 watery loose motions. All the 100% had abdominal cramps, 5% had nausea or vomiting, none had fever or blood or mucus in the stools. No case had dehydration or any other neurological or autonomic symptoms. The peak of the epidemic was reached at about 10:30 am, by which time a total of 19 cases had onset. By evening of 17th August, all the cases had been discharged after observation and supportive treatment. Also, preliminary information had been received that the various items served during various meals in the affected mess are hereby displayed on the screen. And one day before the onset of the epidemic, that is on 22nd of August, in the morning breakfast, omelette, paneer bhujia, bread slices, paratha, ketchup, tea, coffee, water, all these items were served. Quite a nice, lavish menu, I believe. During lunch on that day, it consisted of gravy, aloo matar, curd, rice, dal, chapati, green salad, and so on. They are all shown here. The snacks on that evening, served between 5 and 6 p.m., consisted of aloo bonda, ketchup, and shikanji. There was a lavish dinner because that was a Sunday evening dinner, and also a special after a cultural function for Raksha Bandhan, and that's why it was slightly delayed. Served between 10 and 11 p.m., and it consisted of mutton curry, paneer, butter paneer, dal makhni, fried potato and cabbage, rice chapati, ice cream, salad, pickle water. I am sounding like a waiter, but it's a good watering, mouth watering menu. And on 23rd August 21, that is the day the epidemic started, during breakfast, which was held between 7 and 7:50 a.m. because the students have got to go to the classes by 8 o'clock. And this uh, menu during the breakfast consisted of idli, vada, sambar, coffee, and water. And 7:50, the breakfast finished, and at 9 a.m., rather at 8 a.m., we started having the first case. And unfortunately, but it usually happens that except for the parts of breakfast of 23rd August, no other sample of any other previous meal was available for sample testing. With this preliminary information, let us start with the first step in investigating an outbreak of food poisoning, and this first step is to confirm the existence of an epidemic. An outbreak of food poisoning has three characteristics, which are: firstly, a large number of cases should occur in a small period of time. Secondly, the symptomatology should be usually referable to the gastrointestinal tract and sometimes to the autonomic system in case of mushroom or organophosphate poisoning, or to the neurological system in case of botulinum etiology. Thirdly, the cases should have a history of sharing at least one common meal. Since these three criteria were fulfilled, and also if we recollect, the epidemic curve also showed a classical point source common vehicle epidemic outbreak. Therefore, we decided that this outbreak was of food poisoning and which required further investigations. Now, the next two steps, that is step 2 and step 3, which consist of verifying the diagnosis and deciding which meal to investigate, are generally combined while actually investigating an outbreak of food poisoning. In a food poisoning episode, one has to decide as to which meal is to be investigated, and this is done by making a tentative verification of diagnosis mainly on clinical grounds, while macrobiological diagnosis is always desirable. But for all practical purposes, it is extremely difficult to establish laboratory diagnosis quickly because the procedures are highly specialized, available at only specialized centers, and they take time. More importantly, the food samples are themselves usually not available due to either ignorance or else deliberation on the part of the food handlers. For example, laboratory confirmation of Clostridium perfringens food poisoning requires the demonstration of 10 raised to the power of 7 spores per gram of feces from the patients or from the food handlers, and Staph aureus or mushroom poisoning requires toxin assays which are available only at very few centers in our country. The mainstay is, therefore, to see the clinico-epidemiological profile of the outbreak by quickly analyzing the frequency of symptoms in the present outbreak and comparing this profile with what is expected during outbreaks caused by common etiological causes of food poisoning. In our example, the frequency of symptoms among the 36 affected patients were that the first case occurred at 8 am, while the last case occurred at 3 p.m. And here, therefore, the difference between the maximum and the minimum incubation period was 7 hours. All the 36 cases, that 100% of them, had 6 to 8 watery loose motions, and hence we give them 3 plus. All 100% also had abdominal cramps, so again we give them 3 plus. Only 3% had nausea or vomiting, we give them 1 plus. None of them had fever, we give them a minus. Similarly, none of them had blood or mucus in the stools, so we give them a minus. And similarly, none of them had neurological symptoms or any autonomic symptoms, and none of them had any dehydration or any other complication. Now, the above presentation of the clinico-epidemiological profile as seen in our epidemic, along with the expected profiles for the various types of food poisoning, is shown on the screen herewith. Now, when we talk of food poisoning due to Staphylococcus aureus or Bacillus cereus type 1, the median incubation is 2 hours with a range of 1 to 6 hours. Nausea and vomiting is very marked. As we say, when we say 3 plus, it means that 90 to 100% of the patients would have that symptom. 2 plus means 40 to 60%. 1 plus means that 20 to 30% of patients would have that symptom. And minus means only between 0 to 5% have these manifestations. So in Staph aureus and Bacillus cereus type 1, nausea and vomiting is almost a universal finding. Very few of them will have loose motions, few of them will have abdominal cramps, and none of them will have fever, blood or mucus in the stools, or any neuro or autonomic symptoms. In case of Clostridium perfringens or Bacillus cereus type 2, you will recollect that Bacillus cereus has two types of food poisoning. One is Bacillus cereus type 1, which is akin to Staph aureus, and the other one is Bacillus cereus type 2, which is akin to Clostridium perfringens in its manifestations. Now, in this case, the median incubation is about 13 hours with a range of 10 to 18 hours. Nausea and vomiting is only in a few cases, but loose motions and abdominal cramps are almost universal. Almost 90 to 100% patients will have loose motions or abdominal cramps, and the other symptoms are missing. Fever definitely is missing in Clostridium perfringens, Staph aureus, or B series type 1 and 2 types of poisoning. On the other hand, when food poisoning occurs due to Salmonella species, which is either Salmonella typhimurium or Salmonella sui in this case, the median incubation period is larger. It is 18 hours with a range of 16 to 24 hours. Nausea vomiting is found in almost 50% of the cases, loose motions in almost 90 to 100% of the cases, Abdominal cramps also in almost 30 to 50% of the cases. But what is very, very prominent in salmonellosis is that fever is outstanding. In almost 100%, definitely 90% or more of the patients will show fever and other symptoms are not there. Shigella sometimes causes food poisoning. The incubation period has a range of 24 to 72 hours with a long incubation of 48 hours. The nausea and vomiting is very marked. Again, loose motions are very marked. Abdominal cramps are very marked. Fever is very marked. And blood of mucus is also present in large number of patients. Food poisoning due to insecticides or mushrooms is very short. It takes just 1 to 3 hours of incubation. Nausea and vomiting is marked. Loose motions occur in a smaller percent of cases, but what is very outstanding is the neuromuscular or autonomic symptoms are very, very marked. And similar presentation occurs in Clostridium botulinum type of poisoning. And our episode, what we are discussing, we have till now discussed that the range of incubation period we found was 7 hours. Nausea and vomiting was present in only about 3 to 5% of the cases. Almost 100% cases had both abdominal cramps and loose motions, while the other symptoms of fever, blood, mucus in the stools, and neurological symptoms were missing in our episode. So, from the table now which is being displayed on the screen, it is clear that the epidemic in our example fully matches the presentation caused by either Clostridium perfringens toxin or by Bacillus cereus type 2 type of toxin type of food poisoning. Because in case of Clostridium perfringens and Bacillus cereus type 2 type of food poisoning, the the range of incubation is 8 hours. It was almost same 7 hours in our case. Nausea and vomiting are found in very few patients, same in our case. Loose motions and abdominal cramps are very frequent in these two type of food poisonings, and the same we found in our epidemic here, and the other symptoms are missing both in the C. perfringens and B. cereus type 2 food poisoning as well as in our present episode, and therefore in all probabilities the causative organism in our example was either Clostridium perfringens or Bacillus cereus type 2. So now we have seen that our present epidemic in our example would have been either due to Clostridium perfringens or due to Bacillus cereus type 2. From the epidemic curve, we have seen that the peak of the epidemic came at around 11 o'clock. The first case occurred at 8 o'clock in the morning, and the last case happened at about 3 o'clock in the evening. And also we know that the incubation periods of Bacillus cereus type 2 and Clostridium perfringens, the median is 13 hours, the minimum is 10 hours, and the maximum is 18 hours. So, from the peak of the epidemic, which corresponds to the median incubation period, if you go back by 13 hours, that is 13 hours from 11 a.m. on 23rd August, if you go back by 13 hours, we would reach a point which is around 10 p.m. on 22nd August. Similarly, if we go back by the minimum incubation period of 10 hours from the first case which came at 8 o'clock in the morning of 23rd, we'll again strike at 22 August 10 p.m. And the same thing, if we go back by 18 hours, which is the maximum incubation period from the last case which happened at 3 p.m., we'll again come to the point which corresponds with 10 p.m. of 22 August. And all these three are corresponding with this point of time, and we know that the meal which was eaten at this point of time in the mess was the dinner of 22nd of August. And therefore, it is the dinner of 22nd August which is the meal which needs to be further investigated now. So, we now move on to step number 4, which is to make a line list of all the persons who ate the particular meal which is being suspected. In this step, we make a detailed list of each and every person who ate the particular meal, whether the person developed any symptom or did not develop any symptom. This, in our example, we will make a list of all the 87 students of MBBS first year who ate the dinner on 22nd of August, and each and every one of them will be investigated as per the details we will be giving later in step number 6. And now we move on to step number 5, which is developing the epidemiological case sheet. So, once we have confirmed the existence of an epidemic as well as verified the diagnosis on clinico-epidemiological grounds, as well as we have identified the meal which is to be investigated, the next step is to quickly make an epidemiological case sheet for recording the data from each and every subject. The epidemiological case sheet will look like what is being projected on the screen. So, in our example, the problem we are solving, this would be the format of the epidemiological case sheet. It will have the date on which the data is being collected. It will have the name of the subject being investigated, the personal particulars, and it has an exhaustion that place a tick of right below the box for the item you ate and a cross if you did not eat that item during the dinner on 22nd of August 21, that is the meal which we are investigating. And it lists each and every item which was served during that particular meal. That is mutton curry, matar paneer, dal makhni, potato cabbage, chapati, rice, ice cream, salad, and even pickle and water. Everything is to be included. And suppose the person says, yes, mutton curry I ate, so you put a right here. Matar paneer, no, you put a cross here, and accordingly for all the items. And the next thing which is recorded is a question that did you have any symptoms, yes or no? And if yes, put 3 plus or 2 plus or 1 plus or nil below the symptoms. And 3 plus means that it was very severe, very frequent. 2 plus means it was moderate. 1 plus means it was very infrequent, or nil means I didn't have that symptoms. And all the symptoms which are possible in any food poisoning episode are listed here, that nausea, vomiting, fever, abdominal pain, cramps, watery loose motion, blood or mucus in the stools, neurological symptoms, or any other symptom which is to be specified. Now, suppose the subject says, I did not have any symptom. So you just write no here and everything becomes a cross or no. On the other hand, the person says, yes, I had symptoms. So he writes yes here. And then here he says nausea, no, I didn't have, write no, vomiting, no, write no, fever, I didn't have, say no, abdominal pain, yes, say yes, and very severe, 3 plus. Watery loose motions, yes, I had, and I had about 10 watery loose motions. So you put a 3 plus, and accordingly we put no or yes and 3 plus, 1, 2 plus, 1 plus, or a nil below the symptoms, and that is how the epidemiological case sheet is filled up. Now the next step, that is step number 6, involves getting the food histories about the suspected meal. Once the meal which was most probably associated with the epidemic has been identified, the epidemiological case sheet shown in the previous screen is used, and each and every person who attended that meal is interviewed and asked about the history of consumption of each and every food item that was served during the meal. So in our example, our investigating team made a list of each and every item which was served during the dinner on 22nd of August. These items, to repeat, were mutton curry, matar paneer, dal makhni, fried potato and cabbage, rice, chapati, ice cream, salad, pickle, and water. The team then interviewed each and every of the 81 boys of the first year boys hostel who had attended the dinner of the 22nd of August and asked them whether they had developed any symptom. If they had developed symptoms, then the details of each of the symptoms were inquired. Details were also taken for each and every of these food items, whether eaten or not eaten, irrespective of whether the person developed head sickness or not. Now, step number 7 is the transfer of data to the data sheet, and in this step, the information which has been recorded on the individual epidemiological case sheets is now transferred to the following worksheet, which is being shown on the screen, and preferably it should be done on a computer program as EpiInfo or in Excel. This is how the worksheet will look like. So let us see, this is not the entire worksheet. We have just given the details of the first case and the last 81 subject. So the headings would be the serial number, the personal particulars, whether the person developed the illness or not, yes or no. Now, after this, it has got two important parts. The first part is filled up for those or transferred for those who, if ill, then the presence of symptoms, that is yes or no, and the history of eating various food items served during the particular meal. So the first case, let's say the name was ABCD, and when we transferred the data, we found that he had not developed the illness. So we write here no. And since this is no, all these symptoms will be dash 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 dash. Now we ask this person, what we had asked was each and every item, did you eat or did you drink this item? Matar paneer, he said yes I ate. Mutton curry, no I didn't eat. Dal makhni, yes. Fried potato and cabbage, said yes. Rice, yes. Chapati, yes. So accordingly, whatever history of item which was eaten or not eaten is recorded, or rather transferred, from the individual epidemiological case sheet onto this data sheet. Similarly, this is the data for the last case in our problem which we are solving. The name was XXYZ. This person said, the subject said, yes, I was ill. So now we ask what all symptoms he had, and we found that he did not have nausea, vomiting. Yes, he had watery diarrhea, abdominal cramps were there, there was no fever. As regards eating, he said, I didn't eat butter paneer, but I ate mutton curry, dal makhni, no, fried potato, yes, I didn't eat rice, I had chapati, and so on. So accordingly, the entire data from the individual epidemiological case sheets is transferred to the this data sheet, which is further used for analysis. So we now come to a very important step, that is step number 8, which involves identifying the food item which caused the outbreak. For this, the details recorded for each and every person in the data set, which was just shown to you in the previous screen, these details are now consolidated into a summary table which is being shown on the screen, and I'll just explain to you this table. This is a very, very important table. The first column lists out all the food items which have been investigated, like mutton curry and so on. Now, after this, there are two main parts. First part pertains to those subjects who ate the item, and the second part pertains to the subjects who did not eat the item. Now, for those subjects who ate the item, we find out how many of total were there, how many became sick out of this total, and how many did not become sick. So, like for mutton curry, there were total of 40 boys who gave a history of having eaten mutton curry, and on further evaluation, on further consolidation of data, we found that out of these 40, 31 developed sickness. And then we calculate in this column the incidence among those who ate the item. We also call it as the attack rate among those who ate the item, and this is calculated as B, that is those who became sick, divided by D, that is the total number who ate that item. So B divided by D, in this case it comes, for mutton curry it is 31 divided by 40, so it converts to 78%. Now, the second part is for those who did not eat the item. Once again, we find the total number of boys or subjects who did not eat this item, that is mutton curry. We got a history that 47 of them did not eat mutton curry. We will recapitulate how many total subjects were there, 87. Out of which 40 gave a history of eating mutton curry and 47 said no, we did not eat mutton curry. Out of these 47, column F shows those who became sick, did not eat but became sick, and the remaining are those in this column which did not become sick. And finally, here also we calculate the incidence or the attack rate among those who did not eat the item, and this is calculated as F divided by H, or for mutton curry it is those who became sick, that is 5, divided by the total number who did not eat mutton curry, that is 47, and it converts to 11%. Now, the next very important part is attributable risk. Now, as far as attributable risk is concerned, we calculated as the incidence among those who ate the item, and from this we subtract the incidence among those who did not eat the item. In other words, it is incidence among those who ate the item is E, and incidence among those who did not eat the item is I by cell I, and this is calculated as E minus I. So 78% minus 11%, that is 67%, is the attributable risk of falling sick, getting the disease in this episode due to eating mutton curry. Similarly, this data is filled up for each and every item which was eaten or taken during that meal, and then we proceed further. Now, in our example, our investigating team worked out the data as I have just explained in the previous slide, and the results for the entire data are shown in the screen herewith, and which I'll just explain to you. Now, as I have said, this is the enlarged form of the table, and just explain to you for mutton curry, total of 40 boys had eaten mutton curry. Out of those, 31 fell sick, and the incidence in those who ate mutton curry was 78%. It was 11% among those who did not eat mutton curry, and therefore the attributable risk was 78 minus 11, 67%. Similarly, it has been calculated for each and every item which was served during that meal, whether it was eaten or not. So like we see for Matar Paneer, a total of 61 of the boys said we ate Matar Paneer, 30 fell sick, so the attack rate was 49%. 26 of them said we did not eat Matar Paneer, 6 of them fell sick, and the attack rate was 23%, and therefore the attributable risk was 49% minus 23%, and that comes to 26%. So accordingly, the attributable risk, this table is completed for each and every item from the data set, and then the attributable risk for each and every item is calculated. Some of the items may show a minus attributable risk, in other words, they are protective, but that does not have much significance as far as our investigations are concerned. Now, the item which shows the highest attributable risk or AR is the one which caused the outbreak. And in our case, we found that mutton curry had the highest attributable risk, and therefore mutton curry was the item which most probably caused this outbreak of food poisoning. So, as a sequence in the investigations, we first of all identify the possible meal which was likely to be contaminated, and we found it was the dinner of 22nd August. And after that, we find out which is the particular dish in that meal which is likely to have caused the contamination, and we found that it was the mutton curry. Now we move on to step 9, which involves undertaking an extensive assessment of the sanitary history and food hygiene of each constituent of the suspected food item. As we said in our example, while mutton curry showed the highest attributable risk, it is not necessary that mutton itself could be the cause. There are many other constituents in that dish like meat, tomatoes, grated cheese, condiments, and even water, which are used in preparation of mutton curry. Therefore, in this step now, the objective of investigations is to find out why a particular food item got contaminated so that recurrences are prevented in future. Therefore, once a particular dish has been identified, as per details we have given in the previous step, its each and every constituent, including condiments and water, should be noted, and a detailed history of each and every constituent should be taken. In other words, the entire food chain of each and every constituent of that implicated dish should be investigated from the public health point of view. Now, this complete assessment of food chain will include right from farm till consumer, as Pooja had said during the last lecture. It will include from where the items were procured, what were the hygienic conditions at the point of procurement, when the item was received and how they were stored in the cookhouse, what were the sanitary conditions at the time of cooking, what temperature did the initial cooking achieve, was it at least 70 degrees centigrade or less than that, whether the cooked item was eaten hot and freshly cooked or else it was stored, and in case it was stored, at what temperature and under what hygienic conditions was it stored, and finally, if it was stored, was it adequately reheated before consumption or not. Relating the above steps to our example, till now the possibility in our mind was that the contaminating agent was either Bacillus cereus or Clostridium perfringens. However, once mutton curry was identified as the possibly contaminated dish, the suspicion became strong regarding Clostridium perfringens etiology, since Bacillus cereus is more likely to be conveyed through a rice dish, while Clostridium perfringens is more likely to be transmitted through a meat dish. So the team quickly made out a detailed list of all the items used in making the mutton curry, including condiments, vegetables, and water. They thereafter took a detailed sanitary history of each and every item, starting from the point of procurement till the final cooking and subsequent storage and serving of the cooked dish. They also verified the details by personally observing the hygienic conditions on ground. The investigating team noticed some peculiar and interesting findings. The supply of mutton was through a local contractor. The contractor used to get mutton from a local butchery. On visiting the butchery, it was found that the conditions were grossly unhygienic. The floor was cracked and there was no arrangement for washing the floor, nor there were arrangements of hygienic disposal of excreta of the slaughtered animals. There was no system of starving the animals prior to slaughtering. Animal excreta, which, as we know, is a rich source of Clostridium perfringens spores, was seen lying all over the floor of the butchery, and the raw meat was apparently getting mixed with the excreta. What also happened was that on 22nd of August, the contractor could finally reach the boys' hostel location with mutton and other fresh items by around 1 p.m. since there was a breakdown in his vehicle. By that time, lunch had already been cooked and was being eaten. It was therefore decided to cook the mutton for dinner. So, cooking of mutton curry started at around 5 p.m. and was completed by about 6 p.m. Thereafter, this cooked mutton curry was stored in a large utensil which was kept on a table in the room since there was no arrangement of a big fridge to store such a big vessel. The dish was therefore kept at an environmental temperature of about 32 degrees centigrade for almost 4 hours till 10 p.m., giving, giving optimum time and adequate time and temperature for the heat shocked Clostridium perfringens spores in the mutton to germinate and produce large amount of toxin. At 10 p.m., the mutton dish was warmed to about say 40 degrees centigrade, and unfortunately it was not reheated thoroughly, which could have inactivated the preformed perfringens toxin, and it was served for dinner starting at around 10 p.m. till 11 p.m. Now, coming to step number 10, in which we make focused recommendations based on the findings of the investigations. Now, at the completion of our investigations, we should make specific and doable recommendations based on the actual findings and develop a system of keeping a check that these recommendations are being adhered to. In our example, the following guidelines were put up to the college management for strict implementation, and these recommendations were firstly, meat should not be taken from that particular butchery till such time it comes up to the sanitary standards. Secondly, meat should arrive in the hostel cookhouse latest by 10 in the morning. Third, meat should be lunch dish and not a dinner dish. 4. Meat dish should be at least one to be cooked for lunch. Meat dish should be the last one to be cooked for lunch. Now, next was all meals should be served freshly cooked and hot. Sixthly, no cooked food item should be stored unless unavoidable. The next recommendation was if cooked item is to be stored, the storage should be on ice in an ice box and not stored for more than 4 hours. And lastly, any cooked item, if it has been stored, even if it has been stored on ice, it should be thoroughly reheated to more than 60 degrees centigrade for at least 5 minutes before serving. And now we move on to the last step, which is to make a detailed report. On completion of the investigations, the investigators should make a detailed report of the investigations and should bring out their recommendations for prevention in a very clear and simple manner for implementation by the administrators who are usually non-medical persons. In addition, a research paper should be drafted for publication for sharing the knowledge with the members of medical fraternity. In our example, the team gave a detailed report to the administrators along with appropriate recommendations. It was also published as a research paper. The reference is shown on the screen for any interested audience for a further study. So let us quickly recapitulate from the examination point of view, the important aspects about food poisoning as they are being shown in a summary in the slide, and I'll explain them to you. To define, food poisoning is defined as an episode of acute gastroenteritis or neurological or autonomic disease, which should have three features. Firstly, there is sudden occurrence of a large number of cases in a very small amount of time. So it is explosive. Secondly, there are common symptoms and signs pertaining to either the gastrointestinal tract or neuroautonomic systems. And thirdly, there should be a history of common meal among those who have been affected. Now, food poisoning can be very broadly of two types. One is the microbiological type due to microbes, or else it could be of the chemical type. Chemical type, to take it first, chemical type is not because of microbes but rather due to chemicals in the food which is being processed or eaten. It includes three categories. One is due to insecticides, and usually they manifest with autonomic symptoms, or it could be mushrooms, and they also usually manifest with autonomic symptoms. And thirdly, it could be due to chemical toxicants and additives, as has been covered in another chapter in our book. Now, the main aspect of food poisoning is the microbiological type, and this type is further divided into two types. One is the infective type, which is due to actual infection, the presence of the infection of the organism itself, and second is the toxin type, which is due to the production of toxin by the organism, not by the organism itself, but the toxin creates the symptoms and clinical manifestations. Infective type, primarily there is only one of the type, that is salmonellosis caused by Salmonella species, non-typhoidal Salmonella as we call them, Salmonella typhimurium and Salmonella sui cholerae. Usually transmitted through eggs or custards or toppings like salads and other raw items. On the other hand, the toxin type, there are five types of them which are very important. The first one is Clostridium perfringens, which we just discussed. It is generally transmitted through a meat dish. Usually the dish has been cooked, and after that it has been restored at room temperature for a few hours after cooking and has not been fully reheated to more than 70 degrees centigrade before consumption. The second type is Staphylococcus aureus, again due to toxin, and usually due to infected food handler who has got pustular infection on his fingers or in his upper respiratory tract. It is usually transmitted by custards, toppings, and ice creams. The third one, Bacillus cereus, it has two types. Bacillus cereus type 1 is due to toxin, which is exactly similar to the manifestations produced by S. aureus. The incubation is also the same, but it is generally transmitted by a rice dish. Usually the Chinese dish is fried rice and so on. Whereas Bacillus cereus type 2 is also due to a toxin, but its manifestations are exactly due to Clostridium perfringens. This produces the upper GIT type of manifestations like S. aureus, whereas B. cereus type 2 produces the lower GIT type of manifestations like Clostridium perfringens. And once again, rice dish is the main culprit in transmission of Bacillus cereus type 2 toxin. And lastly, we have Clostridium botulinum, which is a toxin, a neurotoxin, and which is generally produced by tinned foods by the spores of Clostridia. This is the next revision sites. To quickly sum up the important types of food poisoning, Staphylococcus aureus and Bacillus cereus type 1. They both have a median incubation of 2 hours with a range of 1 to 6 hours. Nausea, vomiting, that is upper GI symptoms, are the main presentation. Nearly every patient would have nausea, vomiting, at least 90%. Few of them would have loose motions and abdominal cramps, and generally fever, blood and mucus in the stools, or neuromuscular, neuroautonomic symptoms are missing. As regards C. perfringens and Bacillus cereus type 2, they have a median incubation period of 13 hours with a range of 10 to 18 hours. It is mainly a lower GIT type of manifestations. Nausea and vomiting is very infrequent, whereas loose motions of watery type and abdominal cramps are very, very frequent in these type of food poisoning. Salmonella species, we just said it is non-typhoidal salmonellas. The median incubation is 18 hours with a range of 16 to 24 hours. Now, the outstanding feature of salmonellosis is this: fever. Nearly 90% or more of the patients will have moderate, and some of them will have high fever also. And it also, most of the patients will have loose motions, they may have abdominal cramps also, and a number of them will also have nausea and vomiting. So that distinguishes salmonella on one hand from Clostridium perfringens, Staph aureus, and Bacillus cereus. Shigella species can sometimes cause food poisoning. They have a median incubation of 48 hours with a range of 24 to 72 hours, and they actually present with all these symptoms. In Shigella type of food poisoning, blood abdominal cramps are very prominent. Most of the patients will have cramps. They will have blood or mucus in the stools. Fever will be there universally, and also nausea and vomiting will be present. Insecticide poisoning and mushroom poisoning, the incubation is very short, about 1.5 hours with a range of 1 to 3 hours, and usually most of the symptoms, some of the patients may have nausea, vomiting, but primarily the symptoms pertain to the autonomic system. Whereas in Clostridium botulinum, the median incubation is 24 hours, the range is 8 to 36 hours, fairly long incubation period, and primarily it manifests as neuromuscular and paralytic symptoms. And to summarize the steps in investigation of food poisoning which we discussed, there are certain steps. Of course, the prelude to any investigation is the preliminary information. The first step is to confirm the existence of an epidemic. Second one is to verify the diagnosis, make an epidemic curve, and make the clinical epidemiological profile of the epidemic as we showed you earlier during our discussions. The third step is to decide which meal to investigate. Fourth step is to make a line list of all the persons who ate the meal during the suspected meal. The fifth step is to develop an epidemiological case sheet. Next is to getting the food histories about the suspected meal. Step number 7 is to transfer the data which has been collected on the epidemiological case sheet to the data sheet. Thereafter, step 8 is identifying. A very important step is to identify the food item which caused the outbreak by calculating the attack rates and attributable risk for each dish. And the item which has got the highest attributable risk is usually the item which caused the contamination. The step number 9 is to undertake an extensive assessment of the sanitary history and food hygiene of each constituent of the suspected food item. Step 10 is to make focused recommendations regarding the findings of investigations. And step number 11 is to make a report for the administrators and also to publish a paper. And lastly, what are the basic methods of prevention of food poisoning? In fact, the 5 keys of the WHO to safer food would also go a long way in prevention of food poisoning, and they primarily may include: number one is hand hygiene, extremely important by all the food handlers and all the food eaters also. Second, keep the raw and cooked items separate, because if they get mixed, the chances of infection spilling over from one item to the other is quite a bit. Thirdly is cook thoroughly. This is a very important principle. Any item which to be cooked should be cooked hot, that is more than 70 degrees centigrade, and as far as possible it should be eaten hot and fresh. However, if the item is to be stored, then firstly do not store, but in case it has to be stored, the storage should be either at more than 60 degrees centigrade, or it should be below 5 degrees centigrade, that is in a fridge or on ice. And after the item has been stored, even if it has been stored at a safe temperature, it is always prudent to reheat this item to 70 degrees centigrade before it is eaten again. And fifthly is use safe water and safe raw materials. That involves the entire food chain. We must be very clear that the entire food chain should be examined, and only safe water and safe food should be utilized. So with that, we come to the end of today's presentation, ladies and gentlemen. Thank you very much, and Jai Hind.